Starting in over here on installing the clutch, we're going to put in an OEM pilot bearing because this clutch kit does not include a pilot bearing as it's intended for use on a Mustang. That being said, the rusty is just from it sitting on the shelf in this humid weather. Got some of these beautiful ARP bolts that are going to hold it on. This is a twin disc, so as you see, disc 1, disc 2. But we'll be able to use the standard MC Miata 6-speed alignment tool because this is still a 26 spline input. Let's just take a quick look under the car. There, as you see, we got the turbo over there, got the oil filter perch over there. This is actually the V8 conversion hydraulics line. We'll be replacing this out over here with one of the McLeod 90-degree bleeder units. It includes a bleeder valve off to the side, which makes life a lot easier if you have any experience with bleeding Mustang clutches. Did run into a small thing we did not anticipate. The tube we made is contacting this motor mount. So I need to see what options I want to go with. Either bending that a little out of the way or making another one. We'll see. Okay, as you see, we've got the clutch installed. I removed all the heat shielding under here, and I'd like to say that for any of you who question the durability of this DEI stuff, I installed the DEI, I think 7 years ago or 8 years ago on this car. I did a poor job because they didn't have a template yet, and this was my first installation. And the stuff literally took me, I think, 3 hours to remove it. And I did a lot of damage to the surface here, so I primered the whole thing. So it all looks really nice now, and I'm going to install some more of it. So over here, you'll see that I did some crap. Oh, freaking light. Okay, I did some hammer stuff here to get this out of the way, and I actually cut it shorter. So the space between these was really small. Now the space is pretty much from here to here. That's why the hose clamps are where they are. I left a little bit of excess of hose on here, and there's now a little relief behind here. You may be able to see I ground down the surface just a little bit, and then I hit it with some primer and paint again, so that that has some clearance. Okay, other than that, I've got no new news under here. We're going to start with doing the heat shielding. As you see, I already have some of it, but we're gonna go ahead and cover all this stuff up so I can get this transmission in here. It's actually going to be a couple of weeks before we get another DEI heat shield kit in, and I also wanted to change a couple of dimensions of how things go in, so I went in and just made my own again. But this time, obviously, I did a way better job than what I took out. But hey, like I said, it's been a long time. So I also, I had done some heat shielding a while back when we modified the transmission tunnel. So I went back and I put in all of that tape stuff. Looks really nice. You'll notice the missing spots. Those are where the transmission mounts will be for the V mount that goes right here. And then I will be going back and making this piece, but this piece can be done after the transmission's in. Big objective right now is to get the transmission in. So let's do that. All right, I've got the clutch kit installed. So now that all that's installed, what I ran across is I noticed that my starter was not going to work. And the reason it wasn't going to work is because it's stuck, it's too close on the flywheel. The flywheel for the Mustang, I could have sworn I had run across the information that they were the same exact size. They are not. They are a little bit different. So starters are very close to identical, but not. They use the same gear, but the gear is mounted different positions. So if you notice, when I hold these next to each other, the positioning of the gears is different depths. This one starts at a higher position and sticks out farther to match the flywheel positioning, and this one, of course, as such, is more shallow and pops out at a different position. They both have the same amount of extension, they both have the same gear. It's just this one will work with the EcoBoost Mustang as intended. This one will work with the Miata as intended. So if you do want to go down that path of using these, whichever one you want to use, what I would suggest is getting yourself something like one of the X clutches that's intended for use with an NC Miata 6-speed, and that'll have the same spline count as the EcoBoost Mustang. The only thing I don't know, and I won't be testing, is if the bell housing will be prohibitive of using that starter. So that's something I won't be testing out. I'm going down this path, I've committed to it, so we're going to make just a little bit of a spacer. I think about less than ½ an inch is about what I should need. I'm going to mock it up and we're going to see what I need. Okay, so before we throw in the transmission, it's important that we make sure we take our measurements on the throwout bearing and how far it throws. This is a thing with the hydraulic throwout bearings like this one. So what we do is we need to measure how far it goes inward from the bell housing mounting surface. So what we're going to do is we're going to walk over here, and I've already done all the dimensions, and I spoke to McLeod on the phone since we were using a McLeod throwout and we're using a McLeod clutch. So you measure from the backside of the motor to the fingers of the pressure plate as installed, and I got 110 millimeters. Then from the bell housing face to the maximum and minimum positions of the throwout bearing, I got 125 and 88. So what that means is this is the amount of distance the throwout can move from that position, which does include the 110 millimeters in that position. But we don't know how much we need to compress it, so that's why we talked to McLeod. They said I need 12 millimeters of movement in order to compress that clutch and disengage it. And the throwout bearing, per these numbers, moves 37 millimeters in total. However, the difference between the position of this and the position of this is 15 millimeters. Well, good news is that this is a free movement type clutch, a free movement type throwout bearing hydraulic cylinder. So the first 15 millimeters, it'll just fill the slave cylinder or the throwout with fluid. After that, we have 12 millimeters of which is disengagement. And then we still have 10 millimeters left that it could extend, but we'll have bottomed out on the pressure plate. So that's good. We're within our range of 37 millimeters. A whole bunch of math to say we're safe to go ahead and throw this thing in. So let's install the transmission. We're in here doing the fun part now. So I want to point out a couple of things. Back when I got this transmission and the shifter, I had noticed that I was going to have difficulty getting all of this stuff installed. But with the hole I've cut, as big as it is up here, this will allow me to have the shifter installed before the trans goes up. That's a really big deal because the way the shifter is supposed to be assembled, it's supposed to be inside of a Mustang transmission tunnel, which is way bigger than this. So what I noticed I had to do was I ended up trading this bolt out for a shorter one, and I threaded this thing first, right? This is the first bolt I'm putting in. I have the arms on the side, those are already attached, and then there's the one bolt on top which is not in yet either. So we're going to install those next, and then we're going to get all that tightened up. We're going to stick this thing into third gear so it is as far forward as possible, and then we're going to get this thing up and installed. Okay, the transmission's now bolted up. So you'll see that we have a vent tube. We're going to have to locate that somewhere because on the Mustang it sits right up there, which is on our motor a little too close to the turbo. I'm afraid this will melt because this is plastic. But it is just a regular old clip-on, so we may just clip it over here. That's for later. You'll notice how close my tolerances are in here. This actually is it's just touching up against the heat shield. But what I did is I did jack this up. This is as jacked up as this will go. It is touching up there. So we're going to see how that sits in the engine bay. I hadn't made note of what angle the engine sat at with this transmission in at full height, but we can clearance a little more on the top because that piece right there does stick up. So if I do need to cut a little more out of the transmission tunnel, that's not the end of the world. It'll just make our shifter stick up a little more. Although it would mean I need to change out the transmission bracket. So we're going to take my transmission bracket, we're going to go ahead and install that and then see how everything sits. So as you see here, I've installed the bracket, got the shifter in a nice position, but it does seem that I still have some more angle I need to get out of this drivetrain, so I will need to lift up the back of the transmission. Looks like I thought ahead, and this has some adjustability here, so hopefully we'll get a little bit more out of this, and then if I need to, I'll put another spacer on the other side of this to raise it up. We can always use a longer bolt here, but the bracketry on the side here is pretty solid, and this bracket is pretty well solid as well, so I'm not going to mess with those. We're just going to need to cut that top portion for the transmission. The breather might need to move again. I just sort of clamped it there to get out of the way. So I would like to point out that I have 2 OEM Ford EcoBoost bolts here, 2 on the other side, right there, and then 1 up there. So there is another one that goes on the top left, but there's not a reasonable way to install it. And yes, I could install it. However, if I ever need to pull this transmission back out, I would hate myself, so we're just not going to put that one in. Also, I may have mentioned it before, the oil pan does not receive any bolts from the bell housing. None of those line up. So we're here inside the car, obviously. These are the nice little plates I made. These are holding the transmission up nicely. So in order to install this, is actually much easier than it may seem. You can just reach in here and put a wrench on these nuts, and then you can use the, a gun right here, easy. So as far as this goes, I'm probably just gonna cut this up, maybe over to here. Let's take a feel down here. Yeah, so probably about here-ish. So let's go ahead and mark that out. This is gonna get rid of that. And let's see. That'll probably work. So now I'll take care of knocking that out. Okay, after much cutting and making a giant mess, we've recut the center console, and now the transmission was able to go up 1 entire inch in the back. The way I measured it was the bolt that sticks out of the mount at the bottom stuck out about 1 inch, and I completely made that go flush to the hole. So we still have a little more room to go up if I cut a little bit more here for clearancing that, but I don't believe we need it because the motor is already in a pretty good position. This looks about correct to me, so we'll go ahead and go with this. I'm satisfied. I don't believe I'll have to make any changes to the center console either, but just for reference, that's cut all the way to the front there. If I had to redo the cut, I'd probably just clean cut all the way from here to the seam right here. Now, also, I would probably go back and hammer these inward and then weld them flat on the sides, but that's hindsight. It's not really that important. Drive shaft is now installed. I used 6 of these bolts that come from Mopar, actually. I did some research on bolt sizing and such a while back, and I came up with needing 6 of these. These are Mopar part number 0440361-2. Comes in a pack of 6, which is exactly what we needed. So I got 3 on the front flange, and then 3 on the back flange. A little dab of Loctite on those, and they fit perfectly. Now I went ahead and ran my 8AN to the front, so that thing is through. It's not obviously secured or anything, but it runs to the trunk. I have some more plumbing that needs to be done in the back still, so waiting on some stuff to come in. I'm going to take a 3D scan of the center console area. When I had initially designed this cover that I had made, I did this purely out of just taking some measurements off of how things were sitting, and I did an okay job. But now that I have a 3D scanner, we can make this a lot nicer. So I'm up here, I've got my Shining 3D Einstar, and we're going to go ahead and take that 3D scan so we can make this center console the best it can be. So we got our scanner out. I'm going to start on preview mode. You can see what our preview looks like. All of this is what it's detecting as the surface. Very cool. And I got a button on here that'll start the scan when I get into the car. So I'm going to go hop over in the car. And we can see very clearly in the image on the screen that we got the shifter and the e-brake and such. Now we're going to start scanning so we can get the dimensions and the positions of all these items. Scan portion, and now you can see all the center console, and it looks like I picked up my leg and a bit of the steering wheel as well. But we can go back and we can manipulate the information to where I don't have all of that extra stuff. So cool thing here is what we're actually looking at here is a point cloud. We're not looking at actually solid surfaces. When you start zooming in, you start seeing it's just a bunch of points. This stuff's really cool. I'm not trying to get off into the engineering thing, but I thought if you're watching this, you probably will appreciate what's going on here. So now what I'll be able to do is export just the center section into a 3D file that I can use in SolidWorks to model a better fitting center console so it fits exactly how I want it to. Here and cleaned up, got rid of all of the stuff that I wouldn't necessarily need, and I left a bit of excess material still so I have some more reference points. But this is what it came out to after removing all of that stuff. This is my second scan. I went back and I lowered the e-brake handle, and I also took some more detail around the shifter because the program did not like the shifter and deleted it because it thought it was an error. So the plan here is make it go all the way to the back here, come all the way as part of the front as I can, and then of course as low as possible, so that way you have access to get your hand around the emergency brake. All right, we're back here at the house with my assistant. We have this model up here. So what it is, like I said, I'd simplified this down and then I exported it so I could use it in SolidWorks. Let's go ahead and close this out. We got over here into SolidWorks. Let's look at just the model from SolidWorks. So here in SolidWorks, this is what it comes out looking like. It's actually multiple pieces. It's kind of interesting how it imports it, but it imports it with the full mesh detail. So if we take off the actual borders, it ends up looking like that. So then I took my two models that I had of both the little piece that I just printed out for the switch setup, which is down in there, as you can see. And then also I made some changes to the actual console piece. I made it longer. I accommodated the shifter and the e-brake more appropriately, so those look like they're about lined up. And there won't be any interference in here with that component either. I am making the conscious choice to not make this super long out the back. There's really no reason to extend this all the way back out here. We'll leave this open here, so at least I have some sort of armrest. I did some more 3D printing and some more 3D modeling. So this was the prototype I had made from a while back. The switches fit really nicely into this. It was like a super tight fit, you know. They fit really well. Problem is this is made out of PLA, and also it was on my old printer, so it was, well, it sucked. So I made a new version. This is out of ABS, so it'll definitely withstand the car temperatures and stuff. I also modified some dimensions, so this will use larger bolts. This one I'd made small holes. That's not really practical. These are going to be able to take M6s, but this is the beautiful part. I made this so precise that it takes a lot of effort to get it to fall out. But this let's see. Ooh, there we go. Yeah, the fitment's really nice. So that'll go into the center console. Now I got in one of these. This is a Scosche brand radio surround. So I 3D printed, 3D modeled out of ABS, one of these. And now we have gauge faces. They're singing System down in the background. Anyway, so this will just bolt up really nicely like that, and we'll have two gauges right there as well. So, got it all mounted up. Check that out. Gonna need to cut the legs down on this, because I guess this is meant for a thin panel mount. But fitment is really nice. Back to 3D modeling today. I've made a lot of changes to the center console design, minimal design changes to the side, and a couple of minor changes to where the position of these items are. I also modeled in some more of the objects. So let's make that thing transparent so you can see. This is representative of the shift boot I've got, which is that guy. All I did was I 3D modeled up the base box so that it sits there and looks nice. And I also just got in one of these switch panels. This thing is, it's just 5 switches on a, I believe mine's 5. I got 5 switches, one of them's a momentary. It tells you what voltage you have, and it has two USBs on it. Since I'm not running a radio and I don't have that portion of the dash that has the DC adapter, someone's got to be able to charge their phone, you know. So I decided that I would put that at the front here, and this is just going to be an upward bend, and we'll have that guy sitting there. Now, in order to make space on the underside, I changed the design of my switch holder, and I also modeled in the switch holder as well to be sure that I would have clearance on the underside, as you see. So it appears there is clearance there. But in order to make additional clearance, like I said, on the sides, I ditched my X-shaped design and I moved this more of a, I guess, an H-shaped design. And I'll go ahead and 3D print that guy out, and I'll show you what it looks like. Meanwhile, that's what we're coming up with. This is going to sit just below where the radio is in the car, so you'll be able to reach forward and you'll have your switch over here, and then right below that you'll have your window switches. I'm not entirely sure what we're going to do about an e-brake boot, since the standard universal e-brake boot solutions, they're not long enough, I don't believe, so I may have to stitch something up. And then what I was thinking is I could also make a surround for this that just bolts in, just like they have on those aftermarket e-brake solutions, e-brake EBrake boot solutions. So it would just be like a little trim ring that I design up and put some strategic holes on it. But tomorrow at the shop, I'm going to see if I can't move the EBrake over just a touch more to the left. That'll give me a little more room here, and see how tight it just needs to be. Because as of right now, if I make a trim ring, it won't be able to fit right here because that sits right there. So I believe I'm finished with the upper portion of the center console. So I moved to making the, I guess you can call it the heat shield insert, or the lower console insert piece. It's going to be this rudimentary shape. And as you see how it fits into the console here, the objective is to stop as much heat from getting in as possible, since obviously I've compromised all of this, and normally there would be a little rubber boot around the shifter, and then the EBrake just has a small pass-through for the cable. But in my case, obviously, I got to make something work. So here's where we are. Let's go ahead and show it with everything on top. So I'll show how I've changed all these things. Let's see, working one-handed here. Okay, so as of right now, I'm still not entirely sure if I want to use the race equip boot or do one handmade, because I'm already going to have to do a handmade one for the emergency brake due to the weird shape of the weird shape that it's going to need, because this is a really long, slim cut. And let's see, I moved the switches back to the back again because they need to be out of the way for me to have this switch panel accessible under the AC controls. I didn't want this to be too close of an interference, so I figured I'd just move it forward. So everything looks really nice here. I'm gonna go ahead and send this off and get this made. Okay, we're back here at work. Check it out. My Y adapter came in. The other one's a literal Y where they were split like that. I didn't like that. So I got these, so now they'll be paralleled. And I can also just connect straight onto this, so that'll screw onto there. All right, also my battery came in. So based on my battery relocation kit that I sell, I'm installing an Optima battery and using one of these ICT billet plates. They're really freaking solid, so I'm gonna go ahead and put a couple holes in there, drop some riv nuts in, and that'll stay over there. Then I also got in these, well, this time they're Sunmorn brand. You know, whenever you order stuff on Amazon, it changes name brand. But I use these on a lot of cars because they have two 4-gauge holes, which can also be used as 0-gauge holes or 2-gauge holes. They're pretty awesome. And it has two 8-gauge holes as well, so you can hook on as many things as possible. Since I will be running a little fuse box here in the trunk, I figured it's a good idea. We'll go ahead and run dedicated power out to this thing. This is going to be powering my my two pumps here, and I don't know if I'll have any other electronics on that as well. So that's the next step for installed. Check it out. This is a great setup. That's why I started offering it for my battery relocation kits. It's the Optima red top 1000 volt cranking amps, and with this ICT billet mount and 4 riv nuts, this thing is impossible to move. So it'll pass all your safety regulations, and no one's complained about it. They're really awesome. So I'm probably gonna hold off on doing the positive side wiring until I have all the fuel stuff taken care of. So obviously I got in my Y just because I wanted to see how it hook up. I think I'm gonna end up cutting this back and putting a 90 on this, and then obviously, like I had said in the previous video, I need to cut these shorter. I'm not sure if I want to mount this under here or behind. I don't know. We'll figure something out. All right, we're taking care of doing the clutch fluid today on this thing. So the system's not bled. There's a lot of air in it, and as I should have done, I should have pre-bled the slave cylinder before I installed it into the transmission, but that's okay. We'll take care of it the other way. So this is a Willwood conversion, like the one that's used for the LS conversions. It uses the same quick connect. I just had to get a slightly longer line. The line on here is 26 inches, and it's just the right length. We got the Willwood reservoir. I went ahead and took one of my designs, I modified it, and now I have a Willwood cap, so this fits nicely on here for me to be able to pressure bleed it, along with my little vacuum hand pump. I'll explain that in a moment. So these don't operate on your typical slave cylinder. These operate on a concentric system. So right now it should be in an extended position with air in it. Well, it will be with air in it if you've just installed it. So how do you get that air out of there? You have to put a cap on here of some sort and pull a vacuum. So this is my little vacuum hand pump. Put it on there, and what it does is that pulling that vacuum on here will compress that slave cylinder, so it'll pull some of that air out of the slave cylinder. So the objective here, by getting that air out of the slave cylinder, is that it'll travel up the line so we can more easily bleed it. Allegedly these are self-bleeding, but they really don't self-bleed, especially when the line goes down like that, as you see. So as I had mentioned, I got the McLeod bleeder. So that nice little guy right up there takes an 11mm, and as you see I have my bleeder line on here. So what we can do here is we can just crack that open, apply some pressure at the top like we do with every other system, and get as much air out of the stainless line as possible. Then what we can do is we can also pump the pedal, and that'll also help some of the air bubbles get out. So I've pumped this thing until there's no more air coming out at all. And then what I did is I closed this valve up here, and then I pulled a vacuum on the cap. So what that'll do again is it'll get some of the air to come out of that slave cylinder in here, and it'll get trapped in the line. Then we let it sit for a bit under vacuum so that air gets a time to travel up the line, and then we go back and bleed again. So I did that 3 times now. We now have no air in the line, and the pedal's nice and stiff. Okay, so we're over here in the office. I am missing a couple of these gaskets. It has been forever since I took this thing off of the car, like 4 years. So these are the O-rings that came with it, and I contacted Zero Limit. It's been so long since he's made these, he doesn't remember which ones these are. So I have to measure them manually. I know they're a 1.5mm gasket thickness-wise. I got one of the originals. You can see how it fits nicely. Ta-da. But the thing is, dimensioning these is going to be kind of difficult. So what I did is I took a chunk of wire. This is a 20 gauge wire, so we can measure the length of it. We already know it's 1.5mm. So we're just going to stick this in here, and then what we can do with this is, one of the employees suggested that we just use this as a gasket. It would be a wire and reinforced gasket. You see, that fits. So then what we can do is we can take this off, and then we can just measure how long it is and use that dimension to figure out which one to order. So I'll probably order one size up and one size down from this just to be in the range, but it looks like we're coming out to 6 7/8. 6 inches, 7/8. So we'll see what I can find. So we just got in the shipment of all these McMaster O-rings. We got a variety of them. I've got a 1.5mm and 2mm gaskets. It's because, just like I'd said, we had to measure these and hope for the best. So the ones that we have are 1.5mm, and they are 54mm diameter. So what ended up happening is I did get the 1.5 54mm. Yes, they fit. However, I went ahead and took a chance and ordered some 2mm gasket, and the 2mm gasket exactly fits the entire groove really, really nicely, and it's a little more profound on the top lip, so we're going to get even a better seal. Whereas the skinnier one, yes, it does seal, but you look at this and you can definitely see the difference. All right, can zoom in. So if you look, you can see this one fills the entire gap, and this one, you can definitely see it has some movement. So that leaves a little bit less of a crush on the gasket. We'd like to have as much seal as possible. So we're gonna be running these 2mm. Like I said, these are a black 75 Viton material. We got them on McMaster, 2mm, 54mm diameter. So time to install the intake manifold. So I have this beautiful, brand new from Mazda, I guess new old stock, complete engine harness here. And I've had this for a while. I'm gonna go ahead and use this thing so that way, you know, I have no wiring problems in the future. Specifically, I chose to use this one since I actually have 2 of these. This one has the throttle body portion cut off because one of my idiot former employees thought this was a good one to cut the throttle body wiring off of. But it's okay, we'll just wire in this one. This is for the Porsche throttle body. Okay, I've been waiting a little bit to get these parts in, but my 3D models have come to life. So this is the piece that goes into the center console as the lower portion. My buddy Valenti Design, it's Anthony Valenti, he's out of Dallas if you ever need any CNC work or stuff like that. He took care of making these for me, along with a bunch of other stuff that I have going on. But he specifically left this because the bending kind of was difficult since my cut needed to be exactly on the bend. And unfortunately in the CAD, you don't know exactly, the person who's doing the bending, you don't know what their bend radius is gonna look like. So we did go with the thicker 3mm material, and the bend ended up being right there. So it did become a bit of a problem, but the good thing about this is that it's out of sight. So I'm probably just gonna whack the center out and then just not worry about flattening this out. This is actually perfectly fine. He actually got me 2 sets of them because he was already in the mode and he just went ahead and made them. So I actually already have a set in the car I'm about to show you. But this is the other center console piece, the big piece. And as you'll see, everything came out exactly how I wanted it to. It fits phenomenally as well. So my little set of switches, they fit in nicely. Everything fits. Measure twice, cut once, you know. So the holes all line up with everything. And then this little guy just sits on there. Those holes line up as well. And it sticks through. Hold on, there we go. So those stick through as well. That's gonna look pretty awesome. We're just gonna have the switches hanging out like that. And then we also got the trim ring for the EBrake boot, which may end up going on the bottom side. I'm not entirely sure right now. That is a minimal concern. Oh, I did not take care of pre-drilling or having the holes done on this, because these holes you actually have to make, and I didn't measure where they exactly are, so I figured I'll just match drill them. But that's gonna fit nicely, because look at that, it's right on the edge. So now let's step into the car and take a look at how things are. Okay, so we're now in the car, obviously. This thing fits a little bit loosely as I wanted it to, because I want to be able to put weather stripping under the back side here, under the front side, and under the sides. I'm going to see about putting a little bit of weather stripping here, or some, you know, some foam of some sort to seal this up. And then we're going to put some shielding on the back side of this. The EBrake is not exactly where it's going to be at the end. I'm going to angle it over a little bit more. I found I have room on the bottom to loosen that bolt and slot it over. This got actually installed pointing more forward rather than with the transmission tunnel. The wires will need to be rerouted a little bit. I'll just need to cut back this harness and route these a little bit differently. This guy, I don't know if I'm going to leave this here or put it down the side, like over here. But either way, let's go ahead and show how this goes. The installation of this is a little tricky just because the emergency brake will probably have to be installed after the fact. So we're going to end up doing this. Let's see. Doing this one-handed here. And there we go. Check that out. So like I said, it sits on top of the wires. Depending how things go, I may end up lifting it up a little bit, but you see, my measurements came out spot on. This thing sits exactly where I need it to. Right over the shifter, clears the shifter and everything. And then we have this thing right at the base of the AC control, so I have my flip switch panel right there. Very happy with how this came out. So next step, we're going to move the EBrake around a little bit. I'm going to finalize the underside piece, and we're going to, I mean, hopefully get this thing together soon. So I think this is actually a good position to end this portion of part 2 of the video. I appreciate all you watching and look forward to bringing part 3 to YouTube as quickly as possible, which will also mean that this car is even closer to finished, if not finished. Stay tuned.